Alrighty, Rad Tech gang. Rad Nugget number 2 coming at you is logarithms. Okay. I'm going to attack these in small, digestible, bite-sized pieces. Okay. The first thing we're going to do is answer the question, why? Why do we have logarithms? What's even the purpose of them? In mathematics, everything operation-wise that you have in conventional mathematics has an opposite. In other words, some way you can undo it. If you tie the knot, you can untie the knot. Okay? Putting that in plain language, what's that saying? Well, if we have an addition operation, the opposite of that is subtraction. If we have multiplication operation, the opposite of that, division. Even in more complex mathematics, if we have something like an integral operation, the opposite of that is a derivative, and so on and so forth. Okay? All that is to simply say, when I want you to think of a logarithm, all I want you to think of in concept is go, oh, a logarithm is the opposite of an exponent. Okay? That, as you know, you have a base, you have an exponent, you have an answer. A log is just a base of an exponent. Okay? Let me grab my eraser, and then we'll move into that in more depth. So in order to understand the opposite, we have to understand this in the forward direction. And you can see I have BAE written up here, okay? I'll let you just sit there and noodle on that for a second and say, why the heck did Sean put that up there as I set this up? And you'll see why I'm getting to that in the first place. But for purposes of your exam, you might find that acronym very, very helpful. Okay? But first things first, let's just attack an exponent, a plain vanilla exponent in its forward direction. Okay, so just starting here with something that has numbers. Let's say we have 2 squared equals 4. That right there is an exponent operation. You guys know that. That's easy enough. As we know in plain language, that means 2 times 2 equals 4. If we were to have that same base with an exponent of 3, or as they say, a power of 3, then no, that would be 8. Because translating that down into plain language means you take 2, you take 3 2's, and you multiply them all together. 2 times 2 times 2. Takes 3 of these number 2's. 2 times 2 is 4. 4 times 2 is 8. Okay? Now you know the specific numbers application of an exponent here. I want to make this general and turn this into a general format. Okay? And it would behoove you to really study this general format hard and see if you can commit it to memory. So we have 3 things here. In any sort of exponent operation, you have that first big low number, right? In fact, I'll rewrite that in blue. And go. We call that our base. Then you have the tiny number on top there, right? Right there. That we're going to call our exponent, okay? And then, of course, anything on the other side of the equal sign then, for our purposes, is, well, it's your answer. what the result is of the operation. Base, exponent, answer. You probably can start to understand what these acronyms stands for up here. But for now, we'll focus on this. So you have a base paired with an exponent, which gets you an answer. If I were to then take this color coding and write this generically, that means we have a base raised to the power of an exponent. I'm just going to write it as exp for short, if you don't mind. And of course, if you do that operation, you get the base and you multiply it by whatever number of times the exponent tells you to multiply it by. That will ultimately yield your answer. Okay? Now taking one more logical step here, I'm going to shorten this just a little bit more. Base multiplied by whatever number of times the exponent is going to equal, oh, sorry for putting that in black. I'm trying to keep this color coded. Is your answer. Okay? Base, exponent, answer. Your base, that's the number you're working with. Your exponent is the number of times, or the number of instances that we want to multiply the base together. And that is your result. Base, exponent, answer. Okay? Briefly, before we move on, just to make sure that we cement these concepts together and we have a solid foundation before moving on, do one quick example, okay? We're going to say, let's write down a base of 4, okay? And that has an exponent of 3. And we want to see what that answer is. What's our answer? Well, again, the base, that's the number you're working with, okay? You're working with the 4. That's your base. It's the base. What do you want to do with that base? Well, we want to take 3 instances of it and multiply them together, okay? So 4, 4, 4. How many 4s do I have? 3 of them. That's your exponent, okay? When we complete this operation, that's what will give us what we're looking for in green, our answer. So 4 times 4, we take that. We know that's 16. Then you multiply that together one more time. And you get, oh, got the wrong color here. Let me grab the color. There it is. 16 times 4 equals 64. Okay. I'll erase that again and keep it color coded for clarity. So what do we have here? You have your base. How many instances of our base do we have? 1, 2, 3. We have 3 instances of our base, which, wow, look at that. That's your exponent, right? And that results in green in your answer. 4 times 4 is 16. You take our 16 we just made, you multiply it by 4 one more time, gets your result, 64. Base, multiplied by the exponent number of instances equals your answer. If this concept is foggy or difficult to you, take a brief moment, hit pause on this video, let that soak in. Okay, if you're feeling good about that, remember now this b to the power of e equals a that I was talking about, okay? And we're going to move that over here. And one more time, I can't emphasize this enough. I'm jogging our memory to make sure this is in here. Base, the number we're working with, e, exponent, the number of instances we're going to be multiplying it by, a, answer, the results you get, okay? You see these three letters here, and now you see BAE up here, okay? When you run into a logarithm, okay, it is going to look like this. This is your standard language, if you will, that someone's going to try to express to you. Well, I want to get this exponent and turn it inside out and make it backwards, okay? Just like we said, every operation has a reverse. This is just another one of those, okay? So nothing fantastic, because we're just doing the opposite of an exponent. That's all this is, okay? The way you're going to see that is log I apologize, I used the wrong color there. Base answer equals exponent. Now you can see why I want you to have that BAE memorized. And for purpose of your test, if it helps, when you get to the section and you see this, you go, oh, shoot, now's the time to write up BAE. And maybe write this down here too, right? And let that jog your memory. B, that's your base. A, that's your answer. E, that's your exponent. And you're saying, well, geez, Sean, that sounds like a bunch of gobbledygook without any sort of context. So let's break it down, okay? All these same ingredients are still present that we had in our exponent section, okay? So we're going to take a practical example here. Let's say we have a base of 3, and there was some number, whatever that is, right there, mystery number. And the result of that, or the answer of that, was 27. Okay? So we say, well, we took our base, our working number of 3 here, and we multiplied that by an unknown number of instances to get to 27. How many instances did we multiply it by? That, right there, is what a log solves. Okay? So, 3 times 3, that equals 9. Are we there yet? No. How many instances do we have? 1, 2. Well, okay, that's not enough. That's not correct. Let's take our 9, multiply it by another 3. We're going to add a third instance. 9 times 3. What does that equal? Whoa, look at that. 27. How many total instances of 3 did we need to multiply that? Well, let's count. 1, 2, 3. In the form of your log, you can see I was counting that with my red. on the right side of this equality sign goes your number of instances, also known as your exponent. In log language, base, answer, exponent. So that is to say, if we were to write all this into the form of a log, it would look like this. Log. What's our base? What's our base? What's our number we're working with? Right? 3. What was the final result? Well, 27. Let's put that there. And what we don't know is our exponent. That was the blank part, right? That was our little dotted box up there that we solved for, okay? So all that is to say, when somebody says, well, gee, Sean, I got this base working number, 3, and my final destination, and the answer I got was 27. How many instances of 3 did I have to multiply together to get to 27? Well, that, my friends, is your exponent, 3. So if we were to write this in our traditional language, in exponent language, then do this backwards, we would see 3, that's our working number, our base, to the power of 3, which equals your answer. BAE, base, answer, exponent. Base, answer, exponent. Base, answer, exponent. Why I'm hammering this into your head is because right now, obviously all the operations we're doing here are memorization based. And that's all fine and dandy. However, someday, not too far in the distant future, somebody's going to hand you a log that might look like this. And you go, whoa. I don't know about you, but I can't do that by memory. Because that's not in my times tables that I learned in grade school. So, all that is to say, by having down base answer exponent, base answer exponent, base answer exponent, when it comes time to plug this into your calculator, you know what the meaning is of the number that's going to spit out on your calculator. That's why we went through that whole exercise. Next step, we're going to move to our calculator so that you can produce this here meaningful number.